So in this example, we again want to find the foot of the normal from a point which is hovering above or below a plane. And the plane this time has the equation set up like this. R equals I plus 3k plus lambda 4i negative j plus k plus mu 2i plus j take 2k. So this means that the plane is given in vector format, and the first part here is the supporting vector 1, 0, 3, and this is one of the direction vectors in the plane here with lambda, and the other direction vector in the plane is the one with mu here. So if we write up this plane, we have the supporting vector 1, 0, 3, 1i, no j, 3k, plus lambda 4, negative 1, 1, and mu 2, 1, negative 2. So these two here with lambda and mu, those are the direction vectors. And what we want to do is find the normal to the plane first, which means that we will need to find the cross product of the direction vectors. So that's what we will do. We will go I, j, k and find that 3 by 3 determinant for negative 1, 1 is the first direction vector, 2, 1, negative 2 is the second direction vector, and we will work this out. It is I times negative 1, negative 2, 1, 1, take away j multiplied by 4, 1, 2, negative 2, plus k multiplied by 4, negative 1, 2, 1. Which comes down to 2 take away 1 is 1i, and then it's going to be negative 8 take 2 is negative 10 with a negative up front. That will be 10j, and then we will have 4 take away negative 2, that's 6k. So our normal vector n is the vector 1, 10, 6. Hence, we can now find the line AN. So that is a line through point A and through the point N, and point N is on the plane. That line is 2, negative 1, 3 plus some kind of t times 1, 10, 6. So I've used lambda, I've used mu, so here I'll just choose to use t, at least not lambda or mu. In parametric equations, this line is x equals 2 plus t, y equals negative 1 plus 10t, and z equals 3 plus 6t. And point n is on that line, so n must have coordinates 2 plus t, negative 1 plus 10t, 3 plus 6t. And these coordinates depend on t. Now we will need to intersect the line AN with the plane that we have. So that's the next part. The line AN is the line 2 plus t, negative 1 plus 10t, and 3 plus 6t, must equal the plane that we already have here. 1, 0, 3 plus lambda 4, negative 1, 1 plus mu times 2, 1, negative 2. Now, this is a little bit tedious because now we have to just expand the whole thing for x, for y, and for z. So basically what happens is 2 plus t equals 1 plus 4 lambda plus 2 mu. Negative 1 plus 10t equals 0, take lambda plus mu. And 3 plus 6t is 3 plus lambda take 2 mu. If we work this out further and we rearrange so that lambda and mu and t get to one side, we can get it to be 4 lambda plus 2 mu take away t equals 1. And we would get negative lambda plus mu take away 10t equals negative 1. And for the last one we get lambda take 2 mu, and then we'll have negative 6t over here, and on the other side we can get 0. Now this is a system that needs to be solved, and that's tricky, but as you can see I've written it in this shape already, so we could make it into an augmented matrix. You could use the equation solver on your computer, or you could use the augmented matrix and do a reduced row echelon form, which is what we're going to do today. So the matrix is 4, 2, negative 1, 1, negative 1, 1, negative 10, negative 1, 1, negative 2, negative 6, 0. There's a line there, and there's the augmented matrix. Now if we put that in our calculator here, and I've prepared this little bit. So there's a matrix. It is 3 by 4, and if I go in there, this is the values that we have, right? 4, 2, negative 1, 1, negative 1, 1, negative 10, negative 1, 1, negative 2, negative 6, 0 corresponds with what I have here. So to solve this system, again this is not the equation solver, this is a matrix. I'll just exit this to the normal menu where you would normally, menu 1, do normal calculations. We press Option, and then we choose matrices. Now we're going for the reduced row echelon form there. And then we press Shift and the word matrix here, 2. And then we're going to specify the matrix, which is matrix A, so alpha A. Press the blue button, and here we have our answers. So this one here, 40 over 137, that's for lambda, and mu is negative 7 over 137, and t is 9 over 137. So let's write that up. Lambda is 40 over 137, mu is negative 7 over 137, and t is 9 over 137. Now let's see, I want to find point n. So either I need to substitute all of this, lambda and mu, in my plane, and I will find point n. Or of course, I can take my t here and put it in my line, which may be a little bit easier. So Substituting 9 over 137 for t there, you get 2 plus 9 over 137. And then we get negative 1 plus 10 times 9 over 137, which comes to negative 47 over 137. And then we will have 3 plus 6 times 9 over 137, so that's 3 and 54 over 137. And these are the coordinates of point N.